Strategy dominance can be a very useful idea in game theory, and we can push this idea even a bit further. If a strategy T is dominated for player I, the strategy is basically useless to player I. But here's the thing, all the other players know this as well. So player I would never play strategy T if strategy T is dominated, and all the other players know that player I would never play strategy T. But then why do we even have this strategy T in the game at all? If you just remove the strategy from the game completely, it would not change anything. Because player I wouldn't play the strategy and everybody knows that player I wouldn't. By removing the strategy T, we would get a slightly smaller game in which player I has one fewer strategy. And the smaller game would be, for all intents and purposes, equivalent to the original game. Now we can look at the smaller game, and if the smaller game contains another dominated strategy for some player, either player I or some other player, then we can remove that strategy as well, and so on. We can keep removing dominated strategies and make the game smaller and smaller. This process is called the iterated elimination of dominated strategies. It only stops once we reach a game in which no more dominated strategies exist. To illustrate this idea, let us look at the following example of a two-player game in which each player has 5 strategies. So this is our game. Again, we write this down in a table. And now you can maybe pause the video and see if you can spot any dominated strategy here. The only dominated strategy in this game is strategy 4, and it's dominated by strategy 3. We can check this, so look at player 2. Suppose player 2 plays strategy A. Then player 1 would get a payoff of 2 by playing strategy 3, but only a payoff of 1 by playing strategy 4. So strategy 3 is better here. If player 2 plays strategy B, then strategy 3 gives player 1 a payoff of -1, which is larger than the payoff for strategy 4, which is only -3. If player 2 plays strategy C, strategy 3 gives player 1 a payoff of 0, which is more than the payoff of -1 that player 1 would get by playing strategy 4, and so on. So playing strategy 3 is always strictly better than playing strategy 4, regardless of what player 2 does. So we can remove strategy 4 from the game. We just cross it out, so we ignore this from now on. We now have a smaller game where player 1 has only 4 strategies left rather than 5. Now, once again, you can pause the video here and see if you can spot any dominated strategies in this new smaller game. In this new game, strategy A of player 2 is dominated by strategy C. And again, we can check this. So if player 1 picks strategy 1, then strategy A gives player 2 a payoff of -1, which is less than what the player would get by playing strategy C. So strategy C is better here. If player 1 plays strategy 2, then playing strategy C gives a payoff of 3 to player 2, but playing strategy A would only give a payoff of 1. So strategy C is better again. And the same is true if player 1 plays strategy 3 or strategy 5. So in all 4 of those cases, strategy C just gives a strictly larger payoff to player 2 than strategy A. So strategy A is dominated by strategy C, meaning we can remove strategy A from the game to obtain an even smaller game. Now, it's important to note here that in the original game, where each player had 5 strategies, strategy A was in fact not dominated by strategy C. This only happened after our first elimination of strategy 4. And this is because when player 1 plays strategy 4, player 2 actually has a good reason to play strategy A instead of playing strategy C, because A gives a payoff of 6, whereas C only gives a payoff of 4. So as long as strategy 4 is still included in the game, player 2 would not be able to eliminate strategy A, because it's a good response to player 1 playing strategy 4. But player 2 knows that it's not in player 1's interest to play strategy 4 ever, and therefore this is sort of hypothetical, and strategy A is not needed because we don't need a good response to a strategy that the other player is never going to play anyway. So while we go through this process of the iterated elimination of dominated strategies, new dominated strategies might arise that were not dominated in the beginning. Okay, so after eliminating strategy A, we are left with a 4x4 game. So a 2-player game, each player has 4 strategies. And once again, we can stare at this game for a bit and see if there are any dominated strategies. And once again, maybe you can pause the videos and see if you can find one. In this 4x4 game, it turns out that there is a dominated strategy again. Strategy 5 is now dominated by strategy 2. So we can erase strategy 5 from the game. We are left with a new game where player 1 only has 3 strategies left. In this new game, once again, if you want to look for yourself, pause the video here. In this new game, the strategy B is dominated by strategy C. So we can remove strategy B from the game. Now in this new 3x3 game, player 1 has strategies 1, 2, and 3 available to her, and player 2 has strategies C, D, and E available to her. Is there a dominated strategy in this game? The answer is yes. In this game, strategy 1 is dominated by strategy 3. And then strategy D is dominated by strategies C and E. Actually, both of them are better than strategy D. And then strategy 3 is dominated by strategy 2. And finally, strategy C is dominated by strategy E. Which leads us to a game where each player only has a single strategy left. And so now we can make a good prediction of what will happen in this game. We assume, if our logic is sound, that player 1 would play strategy 2, and player 2 will play strategy E, and the payoff to player 1 will be 2, and the payoff to player 2 will be 5. So this is our prediction for the outcome of this particular game. I constructed this example in such a way that in each step there was only a single dominated strategy in this game. But in general, it can also happen that a game has more than one dominated strategy at a time. And in that case, you of course have a choice which of them to eliminate first. But the order of these eliminations doesn't matter. So whichever order you choose, you end up in the same final game. And this is because if a strategy is dominated, then it will remain dominated even after we remove other dominated strategies from the game. This is not too difficult to see. So because of this, you can eliminate dominated strategies in any order you like. You will always get the same end result. In game theory, we are trying to predict outcomes of games. A particular method to make such a prediction is called a solution concept. And the predicted outcome is called a solution of the game. The iterated elimination of dominated strategies is an example of a solution concept. If, like in this example, the iterated elimination of dominated strategies results in a game in which only a single strategy is left for each player, we call the game dominance solvable. However, we will later see that there are also games for which this solution concept works less well. And because of that, we will learn about other alternative or complementary solution concepts later on.